went through 1-1 and 1-2, I think. Does anybody have any questions? Nobody? I'm listening.
C on the 1-1 work on practice. It's the last question.
Right, are 3 points that are collinear?
Yeah. Well, I said no.
That's true.
Okay.
Are 3 points that are collinear? Are there 3 points that are collinear and coplanar? Do 3 points determine a plane?
No.
3 non-collinear. Exactly. Okay, so that was a good answer. No. Are there 3 points that are on the same line and in the same plane? Right? They don't determine a plane. Right? Okay. So let's move. All right, 1-1.3 now. Again, we're going to try to get through 1.3 and 1.4. So let's move rather quickly. Again, I think this is stuff you covered, so I think you should be fine. All right, use the number line to find each measure. All right, so if we look at number 1, VW, if I'm looking for VW, I'm asking for this from here to here. All right, what's that distance? Right, now, again, the correct answer is 4. Now, what's besides counting, does anybody remember what the rule is? All right, if you're doing IXL, they kind of explain things, but how do you find the distance between 2 points on a line? All right, well, V is 1 and W is 5. So how do you think we got? Yeah, you subtract 5 and 1. However, all right, it really shouldn't matter how you subtract. You should always get 4. So what mathematical symbol is used to represent distance? To represent distance. That's the absolute value. All right, so the distance between those 2 points is always the absolute value of V minus W. All right, so whenever you want to find the distance between 2 points, you can just subtract them and then make it positive. That's exactly what they're saying. All right, so that's kind of the formal definition between the distance on a number line between 2 points. All right, to me, that's not necessary for you to know because you should just know from 1 to 5 is 4. All right, but that's kind of like the technicality. All right, so from T to V, we say it's what? 5. I'm happy with that. All right, does anybody have any questions? All right, tonight you can go back and do the ones I don't do. All right, now we're trying to find the distance between 2 points. So I want to review this with you today. All right, and here's what I want everybody to do on their notability. All right, Z right here is going to be x1, comma, y1. Well, actually, do me a favor. I want you to do M as x1, y1. And what's point Z going to be? Brilliant. x2, comma, y2. So please make sure you do that. Do we know what the physical point is? And the answer would be yes, but I don't care about that right now. Good job, Grace. Come on, just throw that in the garbage. I don't need it. And then grab a seat, open up and we're on the distance formula, which is really important. So hustle, hustle, hustle. All right, so now what I'm going to try to attempt to do today with you is I'm going to try to show you how to write your first proof, all right, for the distance formula. Last year I said that the distance between 2 points is this. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's what the distance formula is. And I used to say to my teacher all the time, yeah, people are making this stuff up, right? Because I didn't know any better. All right, here's the formula. Why is that the formula and who decided it? And why is that the formula? All right, so geometry this year I'm going to try to explain because now you have some mathematical background that you could understand how someone figured this out. All right? So, does anybody remember this? Let's talk about this. A squared plus B squared equals C squared. Does everybody remember that, right? We know that. It's a Pythagorean theorem, right? Dealing with right triangles. Now, I'm not going to discuss with you today how they discovered A squared plus B squared equals C squared, but when we get to this section in the geometry book, I will show you how they figured out that A squared plus B squared equals C squared, okay? So we're going to have to go under the assumption today that we know that that's true. Is everybody with me? Everybody good with that? All right. So now what we're going to do is we're going to blow this thing up so I can show you exactly how the formula is derived. So what do you think I'm going to do to this line segment? I'm going to make it a right triangle. All right? So this right here, somebody already said, is excellent. That's the hypotenuse. And so this leg would be considered A, and this leg right here would be considered B. Does everybody agree with that? Everybody happy so far? Right? So now what I want to do is I want to make a relationship between those two things. So it's just a right triangle. And you would argue that A squared plus B squared equals C squared. How do we get that? And I already told you that that's coming in a couple months. I'll show you how to do that. I'll show you how they figured that out. All right? But right now, you should be able to say, yes, I agree with him. That's a right triangle. And the legs or the sides of the right triangle related as A squared plus B squared equals C squared. Does everybody agree? All right. So now I'm going to move to this part. What is this distance? All right. What is this distance from here to here? Now, wrong. All right. You're not counting 7. I'm asking mathematically, what is that distance? All right. Can you tell me? No. What? You are awesome, buddy. Exactly. However, instead of saying x1 minus x2, but you are 100% correct, mathematically 2 comes before, or comes at, so we're going to go x2 minus x1. But I'm very happy with you. That's exactly correct. All right, listen to what we're saying. All right. Now, what I want to do right here now, guys, is not obvious, but this coordinate right there. All right, and let me do it different, just so you can see. I'm looking at this point right here. What is that coordinate? No, you're not understanding at all what I'm doing. All right, listen to me so I can make this perfectly clear. These points here are not integer values. They're just any x. This z represents any x and y, and this represents what? Any x and y. Now, listen up. Here's how you're getting smarter. Why is this x2, y2, and this x1, y1? Because they are not, you're right, different. The side doesn't matter. It's just that they're completely different what? They're completely different points. I could identify this as x3, y3, but that's not correct. It's what?
It's x2, y1.
It's x2, y1. Right? Now listen to me. We're getting into a little bit more complicated math. So the only way you're going to follow along is ask a question when you're not understanding it. All right? This point right here has the same x coordinate as what? This point up here.
And the same y.
And it has the same y coordinate as that one over there. It's not random. Nothing is random in math. All right? So this coordinate now down here is, let's identify it as x2, comma, y1. Is everybody happy with that explanation? All right? So now I want to put down here for you, A is equal to, and say it again.
A equal to x2 minus x1.
You are brilliant. That's exactly correct. Now, someone who's been paying attention now should be able to tell me what B is. You are amazing. See if you come in and be quiet and listen how things work. y2 minus y1. Brilliant. Now, again, if I wanted this distance right here, because it's vertical, the x2 played no part in it. Does everybody agree with that? Everybody happy? All right. So now look. If you understand that, right, the hypotenuse is the actual distance that we're looking for. Does everybody agree with that? So now, watch how cool. You're just now going to plug in for A, plug in for B, and plug in for C. So, my distance squared. Everybody agree with that? D stands for distance, right? I could also put there what? The hypotenuse. But since we're looking for the distance, let's go ahead and put distance. Is equal to x2, x2 minus x1 squared plus y2 minus y1 squared. Now, he originally said x1 minus x2. Does that matter now? Because we're doing what to that value? Squaring it, right? And if we square it, it doesn't matter if the answer was positive or negative, right? When I square it, it's going to become what? It's going to become positive. All right, is everybody happy with that? All right, what? Well, because I'm putting it into the Pythagorean theorem. Because it's a squared plus b squared equals c squared for a right triangle. Yes.
What was the first distance that you gave? Oh, it's distance.
All right. The hypotenuse is distance, right?
So that distance formula is
Pythagorean theorem. It's all it is.
Oh,
It's all it is. Now, what do I do to both sides if I want to solve for d? How do I undo a square?
you take the square root.
You take the square root of both sides. So your distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Pat yourself on the back. That's a great job. All right? Not many people can do that. Although that's not really what? I don't think it's really that hard, actually. All right, you got to pay attention a little bit. All right, but I don't think that's that hard. You should never ask me what the distance formula is, ever. All right, because you know the Pythagorean theorem, you don't need to tell me that. All right, because every time you can do what? You can make it a right triangle. To me, personally, it's easier to make a right triangle. And I'm going to demonstrate that on question number 6. All right, is everybody happy?
Yeah.
All right, now, because I don't want to mess up my artwork on 5, I just want to leave it there. That's what I wanted you to do for that problem. Now, every other problem, we're going to get the numerical distance. All right? We're going to get the answer. No, we're not answering 5. That's the answer to 5. All right? Right now, I'm going to 6. And I'm going to show you how simple it is for me to do this problem. All right? When somebody gives me this right here, I automatically just make it a what? I automatically make it a right triangle. Right? And then I count. All right? 1, 2, 3, 4, 5, 6, 7. This is 7. And I count up 1, 2, 3, 4, 5, 6, 7, 8. So ES is equal to the square root of 49 plus 64. ES is equal to the square root of 113. Anybody have any questions with that? Now, again, listen to me. We're not putting that as a decimal. All right, which is my argument about the book. All right, they put a lot of things in decimals. We are in exact answers. So we would say that's just the square root of 113. If I wanted to know what the approximate square root of 113 is, I would just type it on my calculator, square root of 113, it would tell you. All right, but the answer is 113. What?
Why don't we do what we just did?
Because it was easier for me to do that.
Yeah,
We
so
can't
why
do
did
that on the other one.
Well, I wanted you, I wanted you right now to understand how I derived the distance formula. I don't care about number 5. Right? That's the answer to number 5. All right, you're not going to have to reproduce that on the test. I don't care. I'm just saying I want you to say, wow, that's really not that hard. It might be hard for me to reproduce it, but the person who figured that out is, not the smartest guy in the world, right? We could sit down and figure that out, is what I'm trying to say. All right? Now it's just the application, right? All we're doing now is finding the distance between 2 points. So, for example, number 7, all right? Here is how I want you to do it. Bless you. Here's how I want you to do it. I don't want you to write all the steps out. I like mental math. It was annoying when I had to write out 30 steps when I could do it in 2. All right, the teacher used to make me write all 30 steps out. All right? Because I was good at mental math, not everybody was. Everybody can be good at mental math. You just got to let me show you. All right? So here we go. Here is the answer to number 7. The distance, or not distance, we could just say Ly, right, thank you. Ly is equal to the square root of 144 plus 81. Right? Because we're subtracting the x's. 5 minus -7, or -7 minus 5. So does it matter what way we subtract? Because we are doing what? Squaring it. And we're kind of doing the absolute value. All right? So 12 squared is 144. And 0 minus 9, or 9 minus 0 is 9. 9 squared is 81. I'm expecting you to get that. Right? And so now Ly is the square root of 225. And of course, everybody knows that's 15. Thank you. Everybody does. Everybody. Okay? Yes.
So the 144
Came from the fact that I subtracted 7 and 5, those two. If I subtract those, that's -12, right? Or +12, depending on how you multiply it. You agree? Or subtract, I'm sorry. All right, just a quick heads up for number 9. Right? So Vm is equal to the square root of 4 plus be careful, right? Because you're never adding them. You're subtracting them. So it's 5 minus -4, or -4 minus 5. Now again, it's good to make the mistakes right now. It's good to say 1. All right? You have to be careful with them. So you say 5 minus, the other value is -4. So 5 plus 4 squared, 81. So Vm is equal to the square root of 85. And you're done. I don't want the decimal answer. Let's say the answer came out to be the square root of 20. How many people can tell me what that is?
Oh,
2
2.
radical 5.
Right, good. You have to know that, guys. You have to know how to break down the radicals. And again, we will get some, we'll review that. All right, we'll definitely review that. All right. Now, midpoint is another thing I could prove real quick. All right. Let's find the midpoint of each. Oh, wait a minute. It just says use the number line to find the coordinate of each midpoint. So we already did that. So you should be fine with that. Now, finding the coordinate of the midpoint. All right, find the coordinate of the midpoint. The midpoint is simply the middle. And how do you find the middle of something? You can look at it in many cases, exactly, but there is a formula. Midpoint is an average. All right? So if you want to find the midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Again, that is the formula for midpoint. The middle of 2 points is the average of the x coordinates and the average of the y's. To me, that was kind of logical. All right? So if I ask for the midpoint for question 15, you should be able to quickly tell me that that is -2, comma, I got you. Negative 2, comma, 5. Add the x's. Negative 9 plus 5 today is negative 4 divided by 2, negative 2. 3 plus 7 might have thrown some of you off. 10. 10 divided by 2, 5. Very simple formula. All right. So now what I need for you to do is making sure that you're highlighting the formulas just in case. That's something that you need to know, right? Your distance formula is definitely something you need to know, but we proved it. And then the distance between 2 points on a number line is the absolute value of a minus b. Those are the 3 main topics for this lesson. Is everybody happy with that? All right. Now, I want to show you 17. All right. And I'm going to make a little, what I say is super easy. So look right up here. Find the coordinates of the missing endpoint if E is the midpoint. So I have a point here, and I'm going to assume this is the midpoint, and this is the other point right here. All right, so I'll just put, does it have
D.
D? Okay. So D is the other point, thank you. All right. So because that's D, here's what I want you to do. F, and let's see who can figure this out. 5, comma 8. E is 4, comma 3. I'm trying to figure out what D is. All right, so somebody tell me what do they think D is? Look at it and be able to tell me. What do you think?
3, comma.
You're awesome. All right. Now, how did he get that so fast? Well, E is in the middle, right? So here's how I teach it. If I started at 5, right? If I started by 5, I walked from 5 to what? So I moved back what? 1. So if I move back 1, to stay in the middle, I've got to move back another what? 1. So that will take me to what? 3. I was now at 8, and I walked to what? 3. So I subtracted 5, right? So if I want to stay in the middle, I've got to go back another what? I got to go back another 5, which would make what? Negative 2. All right? Now, 20 is brilliant. I want you to do 20 on your own. All right? You just have to find the distance 3 times. All right, I think we can do that. All right, let's take a look right over here real quick. Jump to 1, 4. All right, jump to 1, 4. All right, name the vertex of each angle. All right, the vertex is a letter. What's the vertex for angle 4? T, right. Well, this is all very basic. Right, what's the vertex for angle 2? Yeah, you guys got that. That's easy enough. All right, now it says name the sides of each angle. Sides of an angle are the rays. Everybody hear me on that? All right. So if I ask for angle 4, you would say the side would be ray what? TU, right? And what? TS. And I want you to make sure you get the ray in the right spot, going the right direction. All right, just to clarify, we'll do angle 1. Angle 1, the ray would be what? WV, somebody said that, and
WT.
and WT. Now, if you don't know, speak up, but I think that's so basic, right? Very basic. Everybody should know that. All right? The sides of an angle are rays. All right? Now, write another name for each angle. So angle 3 could be called angle WTV. Beautiful. If you want to call it VTW, that'd be fine also. All right? I think that's pretty basic. I don't think I need to go any there. All right, basically, we're not going to be using a protractor, so I don't really care about that. All right? So basically, you're trying to see if it's right, acute, or obtuse. So in this particular case, we would just simply say, what does it appear to be? All right? So NMP. Now, I'm pretty sure you guys all know this right here is the symbol for what?
Right.
That's the symbol for a right angle. All right, if you're less than 90, you're acute. You're greater than 90, you're obtuse. You're equal to 90, you're right. Okay, so OMN. OMN is what? It's definitely acute. QMO.
Obtuse.
It kind of looks like a right. If you said obtuse, I wouldn't even care.
Yeah.
But it does look a little bit greater than 90. So again, just that's not going to be on the test. All right. What's on the test is you have to know what? Whether you have to know the difference between acute and obtuse. That's it.
Because O doesn't go straight through the diagonal of the right angle box.
Well, it's kind of actually. I can't disagree with you on that.
Yes.
But.
It's like 100.
But. All right. So here we go. Now let's look at the algebra. In the figure, BA and BC are opposite rays. If BA and BC are opposite rays, all right, that means this from here to here is what? How many degrees?
180.
180 degrees. Is everybody with me on that? Opposite rays just means they form a line. All right? Remember what I said, 360 degrees is just some random number. All right, that the Babylonians decided to choose because 360 has so many numbers that can go into it, honestly. All right, that's exactly, there's something completely just people made up. All right, when you get to pre-calculus, they're going to show you how to measure angles much more accurately, or not accurately, but with much better meaning to it. All right, and they're called radians. You learn about radians. All right. But right now you have to know that the halfway around a circle is 180 degrees, right? So if you draw a line, the measure of the angle of a line would be 180 degrees. So in this case, EBD is 4x plus 16. So let's highlight that. From here to, EBD would be from here to here is 4x minus 8. Actually, I'm doing 18. So EBD is 4x minus 8. I don't know. I haven't done the problem yet. I'm doing 18, by the way. All right. And the other thing I got distracted on here was this word right here. BD bisects. What do you think bisect means?
Yeah.
Cuts it in half. So BD bisects EBC, which means this. These are congruent. So if EBD is 4x minus 8, what is DBC? 4x minus 8 also. So we could put 4x minus 8. And it says EBC, which is the whole thing, right? Does everybody agree with me? The whole thing from here to here is what? 5x plus 20. All right, so now somebody tell me the equation. Go ahead, Carter.
It's 8.
Good. Beautiful. Exactly right. Exactly. So wait, hold up. Does everybody see that, right? The individual parts equal the whole, right? That right there is called the angle addition postulate. It's the angle addition postulate. Remember, we're going to study postulates and theorems. Theorem is something you can prove. A postulate is something you accept is true, cannot be proven. All right, so again, that's kind of weird that the sum of the parts equal the whole can't be proven. All right, cannot be proven. All right, so in this case, to solve this equation, we would just say 3x is equal to what? So x is equal to 12. Everybody happy with that? X equals 12, right? And now it says find x and EBC. So EBC, angle EBC would equal what?
80.
I think it would equal 80. Because remember, EBC is 5x plus 20, right? X is 12. 5 times 12 plus 20. All right? I feel good about that. Okay, so I've accomplished everything I want to accomplish. Listen, you guys got to put in some time. All right. I'm gonna kind of check, but listen, you guys are big kids. When I tell you to do something, it's not optional, right? So I want you to try to finish up 1-3. I want you to try to do the word problems on 1-3, and then 1-4. All right. You have lunchtime. You come in at lunch and kind of get some work done. All right. You have in the morning. If you want to sit with me in the morning and ask me a couple questions, that's fine. All right. Don't waste any time, please. Get your work done. What? Yeah, that's the deal. I want you to finish 1-3, 1-3 word problems, and finish that up. That's very, very, very easy. All right, very easy.
How much time do we have?